Right, so in this video, we're gonna start doing some memory management. I'm gonna separate this process into two parts. In the first part, we're gonna allocate the memory. And in the second one, we're gonna start separating the game code from the initialization code. And then we're gonna pass the memory into the game code. And there we'll start using the memory. So memory management is a big word. People think it's very complicated, but it's actually not. And in this video, hopefully you're gonna see why it is not that complicated. So firstly, let's start up our code editor and take a look at where we left things. Let's zoom in a bit. And it looks like we forgot to turn vsync back on. So let's do that. Let's compile. That works. Let's run the game. So we had this red cube basically moving along the screen, and we're also printing the FPS. So let's stop printing the FPS because that's gonna get in the way of our other logs. Nice. So now we can start talking about memory management. So first of all, we need to create a struct, and that struct is gonna be called game memory. We're going to create that struct inside SDL Pong.h. In here, we're going to create a new struct called game memory. And all we're going to have in here will be a U64, which is an unsigned 64-bit integer, 64-bit because we're using a 64-bit operating system. So we have a 64-bit memory space, and this is going to be the storage size. And storage is just going to refer to the memory that we're going to allocate. So this will be the size in bytes of the memory block that we're going to allocate. And then we need to have a variable for the actual memory, which is going to be the storage. And that's going to be a void pointer, which is basically a pointer that has no type. You can cast this pointer to any type you want. You can cast it to be an integer pointer, a character pointer, whatever. Okay, so for now, this is all we're gonna have inside of game memory. So let's go back to sdlpong.cpp. And before we enter the main loop, and before we start doing this FPS stuff, let's create a game memory struct. Let's call it game memory, and let's just initialize it to be all 0, which is what this syntax is for. Essentially, it sets all the elements of it to 0. And the only thing we need to do now is allocating the memory. So first, let's decide how much memory we want to allocate. So we have that storage size in here. That's going to be a certain size. So for this game, let's just say we want to allocate 128 kilobytes, which is going to be 128 times 1024. So a kilobyte has 1024 bytes in it, and we're just gonna multiply that by 128, which is actually more than what we need for a game like this. We're not gonna use most of this. We're probably gonna only use like 10% of this maybe. But 128 kilobytes is a joke to the operating system. It's such a small amount of memory that it really doesn't matter at all. Chrome probably uses this much every millisecond. That's a joke, but I'm just trying to emphasize the fact that 128 kilobytes is nothing. So don't worry about this. We could have allocated 128 megabytes of memory. These days, computers have so much memory that it's kind of insane. So back in the day, if we were making this game like 30 years ago, maybe even 20 years ago, we would have been more careful about this kind of stuff. But like I said, in this case, it's really not going to matter at all. So that's going to be the size. The next thing to do is actually allocating the memory. And we're going to allocate the memory using malloc. And we're going to use the game memory dot storage size, and just for good measure, let's also cast this to be a size t, which we're not gonna have. We do, okay, I guess that works, but if I'm not mistaken, we need to include standard def to use size t. Otherwise, I'm not sure what we're using. So let's actually check that real quick. Size t. Here, let's take a look at this. Blah, blah, blah. Oh, okay, so it's actually defined in standard def. Like I said, it's also defined in standard IO, I guess, and all these other ones. Let's just include standard def as well. Now we could place it inside SDL Pong.h, just under standard int. Okay, great. Size t is basically C's way of referring to, let's actually take a look at the definition before I give you a worse one. Size t is the unsigned integer type of the result of size of and offset of blah blah blah. So size t is basically will always be the type of the result of size of. Okay, so that's gonna return a bunch of memory, and we can actually compile this and test if it works or not. Let's put a breakpoint here and let's run the game. Stops, good. Game memory. Let's look at our watch window. So the storage right now is 0. It's basically pointing to null. So the storage size is going to be this much. And let's allocate some memory. And as you can see, we get a value that isn't null. And that means the allocation worked. So that's good. And after we allocate it, first let's actually take a look at the allocated value, the memory block. We can say game memory dot storage. And let's look at the first 128 bytes. And that's not going to be visible because it's a void pointer. So let's cast this to be a character pointer so that we can look into it 1 byte at a time. So as you can see, we have a bunch of zeros in here, which is good, which is what we want. But we also have some garbage values in here, which is not good, to be honest. We don't want to have garbage values in our memory. That's going to cause all sorts of problems for us. We basically want to guarantee before we enter the game loop that the memory block we allocated is cleared to 0. That's really easy to do using memset. We're going to give it the game memory dot storage. We're going to set everything to be a 0, and we're basically going to enter the size here, which is going to be game memory dot storage size. You can take a look at memset if you like, if you want to know what it does. Memset, let's take a look here. So the C library function copies the character C to the first n characters of the string. It says string here, but a string is basically just an array of bytes, which is exactly what memory is. So here, as you can see, we give it the memory, we give it the value that we want to set it to, and then we give it a size t, which we just learned about, which is the number of bytes to be set to the value. So we know the number of bytes, we calculated it here, and we also know the memory location, and we're going to set it to be 0. So let's compile this. Memset is not found, great, because it's inside of the string.h file, header file here. So let's just include that. And then it's going to work. Now let's take a look at our memory block. I'm going to allocate it. As you can see, we have some garbage values here. But after I memset it, as you can see, all of it is set to 0. And now we have a nice big block of memory, which is all zeros. Okay, good. So that's going to be, believe it or not, all the allocations that we're going to do inside of our game, which might be surprising to a beginner, because when you're a beginner, you tend to think in terms of smaller memory allocations. For example, let's say you have an FPS game where you have a gun and you're shooting the gun, and the gun is creating bullets as you shoot it. As a beginner programmer, you might think in terms of, okay, I'm gonna allocate a new bullet struct each time the gun shoots. And then I'm gonna delete those structs by calling free. But actually, that's not a good idea, because every time you're calling malloc, you're taking the risk of basically not receiving any memory. If the operating system runs out of memory, which is finite, it's not going to be able to give you back the memory you asked for. And in that case, your game is just going to crash. Even worse, it might not crash. And in that case, you don't know what's going on anymore. It's all just crazy world. But this way, we're anticipating how much memory we're going to use in this game. So before we even start the game, we have all the memory allocated for us. And we're just going to use this big block of memory. And after we allocate the memory, we're actually going to check. We're going to say if game memory.storage. And only then we're going to enter the main game loop. Because if this allocation failed, it basically means we have no memory and the game will just not run. So, okay, let's copy this whole thing, which is going to be everything here. I'm gonna cut and paste. So we're basically entering this main game loop area only if the allocation worked. And currently that should be no problem. As you can see, the game runs. That means our allocation worked just fine. And that basically concludes the first part of this video, which is just allocating the memory. Thank you for watching, and I will see you in the next one.